Good evening, everyone. Welcome to another streaming virtual star party from the Naperville Astronomical Association in suburban Chicagoland. I'm out here at our Astronomy Education Center in the DuPage Valley Observatory. Oh, I could point out too, it probably says my name somewhere down there, but I'm Drew Carhart, the current president of the club. Tonight, we're going to be showing you some live imaging from our telescopes here. We also have our member Frank Leekar at his home observatory, who will be sharing some views through his telescopes there too. And we have a guest MC for the evening. Janet Ferroni is going to be giving us some color commentary on the objects we're looking at. And welcome to her and her fellow members of her chemist, Professional Chemist Society. So happy to see you all here. We're going to just run through some objects that you may have seen with us before, but there's some of our favorites and some of the best things up to tonight in the sky. Our imaging isn't absolutely perfect tonight. We unfortunately still have smoke from the fires out west going over us here, which making it a little difficult to image some of the fainter things in the sky, but we're going to do our best to give it a try. So, other thing to point out, if you haven't been with us before, we do invite comments and questions. So if you are on Facebook, you can just use the comments column there if you have a question you want to pass along. And our control room operator, Jim, will be watching that feed, and he'll pass along any questions you have to Janet or any of us. And if you're watching on the club website, you can send an email to questions@naperastro.org. And Jim is also watching that, and we'll pass along any questions there. So if you want to, let me switch to sharing the first object that's on the screen over here. I'm going to share it directly with you. Hopefully now. This is I just get it when the wind is shaking the telescope here. This is a big ball of stars. It's called a Globular Cluster. It's in the constellation of Hercules. It's called Messier 13 by our list. And Janet, I don't know if you have wonderful star things to start telling people about, and I can turn over the mic to you.
Thank you, Drew. I will also like to welcome everybody that's attending, and especially the members of the Women's Chemist Honor Society, Iota Sigma Pi. So hello, Iota people. And Drew put up M13, which is a Messier object. And first thing I'd like to do is tell you a little bit about why they're called M something or other. So Charles Messier, his catalog we're going to be looking at a lot tonight, was an astronomer back in the 1700s. And he was actually looking for comets. So anything that was staying still in the night sky, he wasn't interested in, and he gave him a number. He has 110 Messier objects, I believe. And Frank and Rick and Drew, you can jump in at any time if I make a mistake or you want to clarify something. But let's go back to M13. M13 is a globular cluster in Hercules, like Drew said. And a globular cluster is a lightly packed group of stars, and they contain some of the oldest stars in the galaxy. So M13 is about 25,000 light years from Earth. And I don't have a lot to say. I don't have anything extra to say about that. Anybody want to add anything to M13? If not, we can go to Frank. If Frank would like to share his screen.
All right, well, here we go. Let me introduce myself here briefly. That's me. And I have my astrograph aimed at, well, actually, we're going to look at two planets right away. My first object is low in the south, but it actually isn't too bad. We're going to do that, and let's see what we've got. you should be looking at Jupiter. And in fact, if you look carefully, you can see vaguely through the haze here tonight, faint stripes across the surface. So, Janny, you can discuss the chemistry of this big gas giant, and then we'll go to another gas giant right afterwards.
So as Frank said, Jupiter is a gas giant. It's the largest planet in our solar system. It's about Earth. It's about 11 Earth cloth in diameter. It's made up of mostly hydrogen and helium gases. But as Frank also said, was you can see some bands across the Jupiter. Those bands are clouds, and they're clouds of ammonia ice. That would be the top band. There's several bands, the clouds, and the first one would be ammonia ice clouds. Another band that it's a little hard to see, but there's another band, and they're mostly made up of ammonium hydrosulfide. Not a place you want to visit. And then there's also the third band, which is the lowest band, and that's made up of water ice. So there is some water on Jupiter, but like I said, it's mostly hydrogen and helium. One of the interesting things I found about Jupiter was it's got the largest ocean in the solar system, and it's an ocean of liquid hydrogen. Everybody wants to know about the red spot. The red spot is a giant storm. It's about 2 times the size of the Earth. Jupiter has lots of moons. Saturn has the most moons in the solar system, but the 4 moons, we can't see them in the image.
Well, we might be able to. Hold on a second, Janet. Let's see if we can find some moons here. How about, there we go. Now, this is extreme exposure. We can see 2 moons next to Jupiter.
Okay, I don't know which ones they are, but Galileo found 4 moons, and frequently you can see the 4 Galileo moons, which are Io, Europa, Ganymede, and Calypso. So that's what I got on Jupiter. If somebody wants to go to Saturn, Mr. Frank.
All right, let's go to Saturn. I will leave Jupiter on the screen, and we'll just quickly, you'll see Jupiter disappear and Saturn appear. So hold on, we're going to slew, and here we go. And we're going to get a different exposure here. There we are.
I'm just going to point out real quick that Jupiter and Saturn, if you walk outside your house tonight and look straight, basically straight south, Jupiter is going to be that brightest star. It's not a star, but the brightest dot you see up in the sky is going to be Jupiter. And then Saturn's going to be fairly close to it, and I think it's above it and to the left. And then I don't think we're going to image Mars tonight, but if you look straight east, probably right over the top of houses, you'll see an orange ball, and that is Mars, just to point out those 3 planets we can see tonight.
It's 3 good naked eye objects that you can go out in your backyard and see tonight. Saturn is also a big gas giant. It's slightly smaller than Jupiter. It's only about 9 Earths across the diameter. The rings are really bright. Other planets have rings, but Saturn's are made of ice, so that's why they sparkle and you can see them. They're fairly young. They're only about 10 to 100 million years old. The gases of Saturn, like I said, it's a gas giant. It's also mostly helium and hydrogen. Saturn has a solid core. It's mostly metals, and it's mostly iron and nitrogen. And it's surrounded by liquid metals. Another cool thing about Saturn is it has auroras, like the Earth has auroras, and at the poles. And they have the auroras are because of the magnetic field in the ions that are charged that form that really nice auroras that you can see in pictures. But, so if Drew's ready, we can go see Drew.
I don't know whose screen we're seeing, but we're going to change to mine. Okay, this is back to the Valley Observatory and the Ring Nebula, or M57. I do want to point out that it's actually pretty breezy out tonight, so occasionally this is a live video image, but the frame rate is slowed down quite a bit. So you might see that the picture changes every about 5.5 seconds or so. Instead of sending you 24 frames a second like the video camera usually would, we've got it slowed way down. So you'll see it changing with little clicks, but every once in a while, if it blurs, that's because the wind shook the telescope during that time. So otherwise, Janet, all yours on M57.
M57. So that's the 57th object in the sky that our friend Charles Messier found. And it's the Planetary Nebula in Lyra. A nebula with their expanding gases. The gases are ejected from a red giant star that's late in its life, so that's why it's shooting off some gases. What's cool is at the center there's a little white spot. That's a dwarf white star. It's a little hard to see, but there's a white dwarf star in the center of the nebula, and right around that, a lot of helium. When you go farther out, thank you. When you go farther out to like the first ring, that's the inner ring. It's mostly hydrogen, oxygen, and then farther out even more, you get the nitrogen on the surface. So the Ring Nebula is about 2,000 light years away. So, Frank, you got anything in your telescope for us?
We're going to plow through these.
Frank, we can't hear you if you're talking.
I don't know. I like the Ring Nebula is one of my.
Okay.
Oh, Frank, are you there?
Yeah. Okay. But I had to move the camera. That took some time. I think, the next target, but it's going to take me another minute to get it arranged. So I'm going to go to the desktop here, and we're going to show you what we have. Can you see my screen, I trust?
Yeah, now we see your screen.
Okay. Monitor 2. There you go. How's that?
Yeah, we can see that.
Yeah, okay, this is a Globular Cluster M15 then. And we can zoom in a little bit on it. I went to a wider field view to show you more or less how it looks in the, I'm going to try a different exposure here. Hold on. Low doesn't work. We'll try, no, that doesn't work too well. I guess that's about the best exposure right now. I think I have some light coming in from the neighborhood, which is sort of flooding the field. But anyway, this is a nice globular cluster in the constellation of Pegasus.
You can see that what looks like a ball of stars, and there's thousands of stars in that area that's called a globular cluster. Now they're lightly packed in that spherical, so that's a little better. Yeah, so they're lightly packed in that one area, and they're sort of spherical. That's why they call them globular clusters. The M15 and globular clusters in general contain some of the oldest stars in the galaxy. M15 was the first globular cluster known to host a planetary nebula in its center. Now, I'll talk about planetary nebulas. I think we have a few coming up. So, and it also hosts an intermediate black hole, which a lot of them don't. Not the super giant black holes like that are in the galaxies, it's a smaller one, but it's interesting that there's a black hole in a globular cluster that's all stars. Now, M15 is about 33,000 light years away. So all these, am I right? Yes, all these objects that we've been looking at are in our own galaxy. And we'll look at a few that are outside our galaxy later on. But, is Drew ready? Like setting up.
Yeah, you're really racing us here. Okay, I have the Dumbbell Nebula, and this is going to be a little bright. I should really turn this exposure down because we're in a little brighter part of the sky. But there we go. There is M27 the Dumbbell in Vulpecula.
This is a really nice nebula. This is a planetary nebula. And it's actually the first nebula, the first planetary nebula that was ever discovered. Planetary nebulas are like other nebulas, that their gas has been blown out from a star. And I think that was, did y'all see that? The nebula was outlined for us. This is interesting. So there's many knots of dust and gas in this nebula. And the inner part of the nebula is lots of dust and gas, and it's mostly oxygen and hydrogen. The outer portion, farther out, you can see some colors. So the inner part, the blues, are oxygens and hydrogens. And if you go outside that, you can see some of the greens and bluish colors. That's because there's sulfur and nitrogen in the outside parts of the nebula. Dumbbell Nebula M27 is about 1,200 light years from Earth. Frank's turn. I'm going really fast. I talk kind of fast. But while Frank's setting up, I was telling you about Frank's telescope. His telescope is
something about the dumbbell on this screen here. I think you can see my pointer there. Can you see my pointer?
Yes.
Okay, so that is the white dwarf that runs this nebula. That's the Parrot Star of the nebula. So that was the star that became a pulsating red giant and blew off its outer shell, and is now shrunk down to a white dwarf. So that star is probably about the size of the Earth, and it probably has a surface temperature of around 200,000 degrees. And so at that high temperature, it's mainly putting out ultraviolet light, which is what really makes the gases in the cloud around it fluoresce.
And the different colors are because of the different elements that are in the nebula.
Correct. So I don't know if Frank is ready yet, or if you want to look at the dumbbell for a minute more.
I am. We're just going to give me another second here, and here we go. Okay.
Ooh, what do we have here, Frank?
That is M31, the Andromeda Galaxy.
Oh, this is a huge galaxy. It's our neighbor galaxy. So since it's a galaxy, it's not in our galaxy, right? So
different exposures, I think, yeah, that probably is the best bet right there.
Well, Andromeda Galaxy is our nearest galaxy, and it's so big you can see it naked eye.
In fact, you can see the satellite galaxy. Now, which one am I looking at in the satellite? I have to zoom in. We have one of the satellite galaxies. I believe that's NGC 205, but I'm not sure. I think that's this one here is NGC 205, I believe. Boy, is the smoke making the sky yellow tonight.
Oh, yes. The fires out west, the smoke from the fires out west are getting caught up in the jet stream, and they're getting pushed into our area. So we have a lot of smoke in the area. That's why you got so much color, yellow color, that we don't usually get. So the Andromeda Galaxy is our closest neighbor. It's the closest galaxy to the Milky Way galaxy. And it contains about 1 trillion stars more. That's about 2 times more than the Milky Way, which has about 200 to 400 billion. So but then the Andromeda Galaxy and the Milky Way galaxy has about the same weight, same mass. So even though the Andromeda Galaxy is much larger, the mass is equal to ours, about equal to us. Now, one of these days, about 4 billion years from now, the Andromeda Galaxy and the Milky Way galaxy are going to collide. So that's expected to look like an elliptical galaxy instead of the spiral galaxies, which both Andromeda and the Milky Way galaxies are both spiral galaxies. Frank, you want to tell us a little bit about your telescope?
Oh, well, yeah, I wish I could show you a picture, but I don't have a picture loaded tonight. The telescope we were using for Jupiter and Saturn is a 10-inch Ritchie-Chrétien astrograph, and I had that set up for planetary work, which it's really not designed to do. It's more designed for deep sky. However, it would take too long to convert it to deep sky for tonight. So the telescope we're using now is actually my 132 millimeter, roughly a 5-inch apochromatic refractor. The equipment, the camera I'm using is an Otic Infinity made in Great Britain, and it's stacking images every 5.5 seconds. It's adding an additional layer of image to the picture. So that's why you may have noticed over the last few minutes, the image is getting a little brighter and more intense. I will change the exposure a bit and see if in fact we can get a better, well, no, that's not gonna work either. Let's try mean SD. Well, I'm looking to see if we can find some of the detail. Not really. Because of that smoke, I just can't get any view of there's a dark dust band, which normally I can photograph. But, well, yeah, sort of. This might be a bit of it here. I'm not sure. Can you see my arrow there, that little darkish area? That could be part of the dust band that runs along the edge of the galaxy. We're looking at the galaxy at an angle of about 45 degrees. So this is not straight on, it's not on an edge, it's just sort of facing us at about a 45-degree angle. So the actual galaxy in the sky is quite big. It's about 2.5 to 3 degrees. That's about 6 times the diameter of the full moon. Many people ask when, how much magnification, how big is your telescope? Normally, you don't really need a lot of magnification. There are some exceptions, planets being one of them, but in most cases, the objects are not very small, but they're very faint, and in this case, I had to use a wide-angle telescope in order to even get even part of the galaxy. The galaxy actually extends well beyond the edges of the frame that you see here. And again, I did mention we do have a satellite galaxy over in the upper corner there, just above the Andromeda Galaxy. And as I said, I believe that's NGC 2005. So Drew, I'm going to try to switch to the double cluster. It may just be coming into range. So if you want to switch to you and see what you can find, I'll try to find that.
Frank, let's see what Drew has.
Are we back?
You're on.
I'm live? Okay. I have having a lot of difficulty in getting a galaxy on screen here. I was trying for a smaller galaxy, and the haze in the air is really obscuring the view. I'm going to try to adjust the camera a little bit more. So I don't know if you want to stare at Andromeda for a little bit longer or what, but I'm really having trouble getting anything that's a presentable image here.
You talk and focus.
I can show you some clusters here. Hold on a second. I think we should be in business. What do you see?
We see your desktop, but we don't see.
How's that?
Yeah, now I see it.
Yeah. I'm going to move the telescope slightly to see if we can get that better positioned. Other direction. Okay. You'll see the telescope, the stars moving. This is the double cluster in Perseus. Okay. And now we'll take a longer exposure of this and see what we have. There we go. Again, how yellow that is tonight.
So these are.
I'll go to a medium range just to give you a better view of the clusters. We can see it as it builds up the image.
Can you use your cursor and show us the two clusters?
These are two clusters. They're NGC. I'm looking at my star chart here. NGC 66. I can't quite read. There's so many stars in the field here. I can't quite read the numbers. Anyway, yeah, they're not really related as I recall. One is actually closer to us than the other, but they just happen to be lined up by chance, and they form a beautiful pair in the sky.
So these are open clusters as opposed to the globular cluster we looked at earlier. Open clusters are groups of stars that are loosely bound together by mutual gravitational attraction, but they're just farther apart. The two that are on the screen that Frank's showing us, like he said, are not associated with each other. They just happen to be in the same area when you look at them through a telescope. The two clusters, one's closer than the other one. I don't know which is which. But you can put one down in the lower right-hand corner and the one kind of off to the left.
Yeah.
Way up.
I just put a color correction filter in so the stars look a little more normal rather than that sickly yellow color. It's a little closer to what reality is here. I'm going to again adjust the exposure a bit. No, we'll continue to use a medium exposure. It's still pretty hazy here tonight. There are several other open clusters too, and we can try for one M11, which is visible to me. If Drew has something lined up while he shows you that, I will try to go to M11. Drew, what do you have for us?
Well, real quick, these clusters are NGC 869 and NGC 884.
Okay.
Frank, go ahead to what you want to go to.
No,
All right, I will just leave this on the screen and I'll stop this for a second.
And also NGC stands for New General Catalog, and this is a different listing than the Messier catalog that Janet was talking about earlier. So this catalog has somewhere around over 7,000 objects in it, where Charles Messier had 110.
Yeah, there's some overlap, isn't there?
Oh yeah, definitely. Yeah, things that have a Messier number also have a NGC number associated with them.
He's more more encompassing. There's lots of different catalogs out there, but the most common are the Messier and the NGC. Frank, you're trying for M11?
I think he had to move the dome again.
I think I heard it squeaking.
Yeah. This would be in the northern sky, and the M11 would be in the southern sky.
So what Rick and I are talking about when he says that he's got to move the dome, Frank has his telescope is in a room that has a dome-shaped roof on it, and it's got a small hole in it, or slit.
Okay, we have it. I'm just going to move this again.
The dome, so that the telescope could see out of it. What do we got here?
I'm just centering it. This is a cluster M11.
Oh, M11, that's a nice one.
We're just going to get it centered here. Again, it's pretty low, so that's why it's very yellow, even with the correcting. Oh, wrong direction. Okay. I'm going to slow this down a second. Hold on, and we'll get a better view here in a minute. I just want to make sure that it is moving in the right direction. Anyway, this is another open cluster, as they are called. And okay, come on, go other direction. There we go. It's moving in the right direction now, slowly but surely. And now we'll go to there, and okay. Here we have M11. And this
M11
there we go. This is one of the densest open clusters. It's almost a globular, but it really isn't. It's an open cluster. But it's in the constellation of Scutum. And even binoculars, you can see this cluster is a little fuzzy haze, but it's a very nice cluster.
This one is also called the Wild Duck Cluster. People like to give them names. I have a trouble seeing any wild ducks in here, but they kind of gave it this name because it's V-shaped. So the way ducks fly, I guess. But yeah, this is again a bunch of stars that are loosely bound by their gravity. I don't know how far away it is. I didn't write that down. But,
yeah, we're going to see who else is.
Besides the Pleiades, this is probably one of the prettiest open clusters that you could see in the sky. I would say the Pleiades is the prettiest, but this one's not far from it.
Yeah, Pleiades is real nice. This is real nice. This is and these large open clusters, like Frank had said, you can see these in a nice pair of binoculars. So you can see a lot of things in binoculars. You don't need to have a big telescope.
We did manage to get another object in.
Okay.
Reasonably good on the screen. I hope it's visible for you when you're ready for.
Okay, take over. I'm going black here.
nice. And one of the things I wanted to say is when we say that I've been telling you that you can find in the Sputum constellation, that's kind of the way we can identify someone else that we can go to the wild duck and tell them it's in Sputum. Or you can tell them that the Dumbbell Nebula. Oh, that was a bad one. I don't know how to pronounce this one. You help?
I can't really hear Janet too well, but so if you're seeing that on the screen, I managed to unfreeze my camera software there, and you're looking at a galaxy. It's called NGC 7331. It doesn't really have a fancy common name to it, so we go by the NGC numbers for it. It's in the constellation of Pegasus. It's actually in a cluster of galaxies. Most of the other ones in it are farther away. For instance, so you're looking at a spiral galaxy that is tilted away from us. So here's its nucleus, and then its arms make a big oval around it because they're a disk, but we're looking at it obliquely. You can actually see a little bit of the dust lanes in front of the nucleus here. And it's not a very good night. It took me a while to get an image that even looks this good of it because the sky is so smoky, but you can see one of the other galaxies up here, this fuzzy thing. The other dots around are stars that are in our galaxy and foreground objects, but
Drew, is
there are
this
a few other little fuzzy things.
Drew, is this 7331?
That's correct.
So the common name for that is, they call it the Deerlick Galaxy.
Well, actually, it's the Deerlick Cluster.
Or the Deerlick Cluster.
Yeah, it's it's the brightest galaxy in the Deerlick Cluster. So off the screen over in this direction. No, wait a second. This is a backwards picture, so it's up in that direction. Is a little group of galaxies together called Stefan's Quintet, and they're a real challenge object for people with pretty good-sized telescopes because they're all quite faint, but they're famous with observers because they're a test of your equipment, your sky conditions, and your eyes. So, but yes, you got the two that you can see. Again, they're both pretty far from us. I don't have a distance written down here, and I can't even look that up. But oops, I mean, be doing that. But the one that's the fainter one there is in the same group, but it's considerably farther away. I think the distance to this is something over
about 40 million light years.
Yeah, I was going to say it's something over 35 or so million light years, just by the size it is on the screen. So, and then, oh yeah, there's actually another little one on the computer screen here. I can see another one up there. It's another little nucleus of a galaxy. So,
yeah, that's very
with our video cameras out here on a good night, without the sky unfortunately filled with the smoke from the west of the United States all on fire now, and no moon up, especially looking overhead, we've had as many as 25 or 28 galaxies on the TV monitor like this at one time, seeing with the reach that the sensitive camera can do, looking at these clusters of galaxies. But anyway, this is a pretty one. Most of the galaxies we'll observe aren't anywhere near as big as Andromeda that Frank was showing, so they fit more in telescopic views. And pretty ones like this are a real pleasure to look at visually. So not necessarily from Chicagoland, but especially if you can get out in a little darker place.
If you got out darker, you could see some of the spirals. What's interesting is that sometimes this is called our twin galaxy. It's about the same size, same shape, same mass. It has a supermassive black hole in the center, the spiral arms. The difference is that Milky Way is a bar galaxy. That means there's a bar of stars across the center of it. And this one is not. This is does not have a bar. So this is, there's been several supernovas that have been spotted in this galaxy area too. That's really nice. And it's quite a bit farther than most of the other things we've looked at because this is not in our galaxy, obviously. This is its own galaxy.
I do have another target, and one that I think, Drew, you wanted to get originally, but I managed to get. So if you want to switch, I think you'll be able to see M17.
M17. Ooh.
Are you getting that?
This is the Omega Nebula.
Yes.
No, that's not Omega. That's the Swan.
Well, the Swan, isn't that also the Omega? I think it's multiple names.
I thought Omega was the Eagle.
No, this has the little ring, the Omega shape on it. So maybe who knows? I love but I thought this was also the Omega, but I call it the Swan too. The Swan, of course, right now is upside down, but we have a neck here and a body here, so the Swan is swimming upside down. But there he is.
You are correct, Frank. It is also the Omega.
Yeah. Okay.
It's also the.
I see that as an upside down swan, though.
This nebula is in Sagittarius. Is that right?
Correct. Yes.
Yeah, and it's clouds of ionized gas. These gases are mostly hydrogen, and the hydrogen atom is excited to the next orbital, and as it comes down, it emits that red light. So when it comes back down to ground state, that's how you get those red lights. So M17, this nebula, is a large star-forming region in our sky, and it's pretty close compared to some of the other objects. It's only about 5,000, 6,000 light years away from Earth. I like this galaxy, or this nebula. It's a nice nebula. You don't often see colors because things are so far away.
Yeah, I could saturate it a little bit, but it'll be, there you go. But you're getting a lot of, electronic noise. But you can see that the nebulosity extends well beyond the Swan figure itself. In fact, it covers practically the entire field here. And this field is about, I think this is about 20 arc minutes across. So yeah, it's a pretty good sized nebula. Now there's another one. Drew, do you have something? Otherwise I have one other which I can swing to very quickly here. Drew, apparently. Shall I swing, Jim?
Give them a second. They need to unmute.
Okay. I'll just do this.
Actually, I was just looking at Saturn with this telescope here because I didn't have anything else on my list, but I was experimenting with how many moons I can see of Saturn. There's actually quite a few of them out there, but I don't know how much you showed them.
We got a news camera.
I can't hear Janet.
Why don't you share your screen, Drew, and
Okay.
And then Frank, you can go to your next object.
Alrighty.
So pardon seeing the menu on the screen, which is really annoying, but so when I went down to Saturn, I had the camera set for the exposure we were using on the galaxy up overhead, and Saturn almost filled the screen as a big burned out white patch. So we're turning way down here, but there's Saturn dancing in the bad seeing. But if I go up on the exposure, now we're going to start seeing off to the side here. These are all moons in here. This is a moon there. There's two more just popped in. So there's 4 on. There's 4 along this side. There's 1 over on this side. There's 1 there. I'm seeing a little better. I'm trying to get the exposure to go back down, and this camera is sticking again. But see if it pops back down.
So the 3 on one side and the 1 on the other side, those are the Galilean moons, right?
No, the Galileans are around Jupiter. So there we go. So
They are
yeah,
there.
these ones here, there's actually a 4th one a little closer in that I can see. This one here is, I have no doubt, is Titan. So the big bright one here, because he's farther out. His orbit's quite a bit farther out, and he's the brightest thing you'll find by Saturn. Actually, sometimes Titan appears like way over to the side because it's got a fairly wide orbit. But they go up to even a little brighter. I'm not sure if anybody else is going to pick up. But this is the difference in brightness between these different objects. To get Saturn so it's nice, we lose the moons because they're so much fainter. So this is a thing that your eye can do in looking through a telescope. I always say to people that a camera like this is amazing for looking at faint things like the galaxy or the gas clouds because of the sensitivity of the detector in the camera. Your eye, on the other hand, is much better for looking at planets or the moon or anything that has detail on it because your eye has so much better resolution than the camera, and your eye can also adapt to a much wider range of brightnesses than the camera can at one time. Again, I can reset the camera to see faint things, or I can reset it to see bright things, but it can't do both at the same time, whereas your eye looking through the telescope would actually see a clear Saturn and the moons by it because our eyes are so adaptable. So, again, the main reason we use the camera for looking at the planets or the moon is just to be able to share it with people. It's much preferable to be using your eyes for things. Some people actually feel that your eye is better for everything through a telescope because you're actually witnessing the light. If you were looking at that galaxy that we were just showing you that's 40 million light years away, you've got light from probably 100 billion stars that's been streaming across space for 40 million years, and then it shines into your telescope that gathers it and puts it into your eye, and so you're seeing the photons that came out of the atoms of these stars and the atmospheres of these stars, and that are incredibly old. And those photons that you see, nobody else is ever going to see. They were your personal little bits of those galaxies or those stars or those gas clouds or whatever. So that's kind of the joy of actually having a telescope that you look through is you get a connection with the stuff out there. But we are not in a time when we can share our direct use of the telescope with you all looking through the eyepieces here to see things. But hopefully we'll get back to that before terribly much longer. And we invite everybody to come out here. We have open nights all year round at our observatories here. And we also travel around with our telescopes to area parks and things too. So anyway, back to if Frank is ready for his next object.
Yes, I am. Hold on. And here we are. Oh, wrong one. Hold on. 1, 2. There we go. How's that?
It's good. Is that the Eagle?
That is the Eagle. Indeed it is. Again, it's getting pretty low, and I'm trying the actual Eagle bit is right around here.
So Frank is showing another nebula. This is the Eagle Nebula. Everybody's seen pictures of this on the Hubble. It's another large star-forming area. But you can see how big it is, and the nebulosity from the stars that the gas from the star.
Yeah, this is getting quite low on the in the sky now. I will. Yeah, that's you can see it's pretty faint. I will kick it up to high. Well, that's too garish. So about that exposure should do it. But yeah, this is now, let's see, how high is this? Yeah, it's only 19 degrees, no, 20 degrees above the horizon right now. So it's pretty low in the smoke and other goodies. Yeah, you can just the structure's beginning to show here a little bit.
Okay.
So I'm not sure what else is in the neighborhood here. We have what? We have about 5 more minutes.
Well, one thing, I posted this on Facebook, but inside the Eagle Nebula is what's known as the Pillars of Creation. And it's a pretty famous, I think it was a Hubble picture that was taken that shows this. I'm gonna post a link in the Facebook page to show.
Yeah, I actually have a picture of it, but I would have to hold on if you.
Yeah, if you could bring that up, because that's.
Yeah. Let's see here, pictures. And now we're going to go back. Infinity, no images. I'm trying to find what is the M number of that again?
It's M16.
M16.
Your NGC.
Okay, I
611.
Deep Sky Catalog. Diffuse Nebula. I got the horse. Well, here, yeah. I wish I had that. I guess I don't have that in.
Okay, I posted a link on Facebook where people can check it out. It's a probably most people have seen that picture before. It's such a
it's classic. Here is one which you might find interesting, though. I'm going to close this off. This is one I took last winter. And I think you might recognize the horse head.
Yes. These are this is another star forming region. This is the horse head is a lot of dust in the area. It happens to look like a nice little horse.
And here is one now. I should mention the colors of these things. I use black and white cameras. I mean, an astronomical camera. It's a black and white camera, and I use different filters to get different light. This is the light of hydrogen, H2, ionized hydrogen, and that's why. That is normally a red color. This next shot is the Crab Nebula, and this is 3 different exposures stacked on top of each other. One is hydrogen alpha, the other one is sulfur 2, which is, and then finally is oxygen 3. The hydrogen alpha I put in the red channel, the sulfur 2 in the green channel, and the oxygen 3 in the blue channel. And you stack them all together and you get basically a false color image. The actual nebula isn't quite as colorful as this. It's basically all red. But the reason they use these different filters is to give a different analyze the chemical compounds which make up the nebula.
This is M1, the Crab Nebula, and this was actually a very recent nebula. It wasn't it like 1500 or 500? The Chinese reported that.
Yeah, like 1064 or something like that. Yeah.
Yeah. So this was a star that went supernova, and this is the remnants of that star.
Well, we are coming up on an hour, folks. So It's when we usually draw the curtain. And so here is Jupiter as it's setting from this observatory here. I forgot, and actually I just noticed it. Now it's getting really blurry again. Jupiter is getting quite low in the sky, and that yellowish color, that sort of sunset color, is, as Frank noted, it's, again, we're looking through that smoke that's coming over. But I had forgotten. I noticed it when I first went on that there is a little moon shadow on Jupiter, but it's not really terribly evident. It was just coming and going over by the edge over here. That's the shadow of Io. Of course, planets like this are lit up by sunlight. So the sun is basically, from Jupiter's point of view, it's kind of behind where the Earth is. So the sun is shining. We're seeing the pretty much fully lit face of the daytime side of Jupiter. But it's 4 big moons as they go around. Each time they pass around, when the when their tilt is correct, which it is now, they make shadows across the face. So there's a solar eclipse going on, and we can see the shadows as little black dots on the cloud of Jupiter. And again, I could detect it there on my screen here, but it's really turbulent. You can see some of the banding, I think, probably on your screen, but the shadow's not going to pick up too easily. But anyway, at that point, it's kind of time for us to call it an evening, unless you had anything else you wanted to close with, Janet?
Nope, looks good. I just want to invite everybody to come down to the observatory when we're open back up. You can find the direction information on when we have public nights on the NAA, Naperville Astronomical Association's webpage.
It's true. And if you're on Facebook, I think there's a link there to our homepage. But wherever you are and whatever device you have, if you're looking for our club, if you just search with your favorite search tool, your favorite search engine, for the words Naperville and astronomy, we will be at the top of the list probably. And we do have a calendar page. We have our 2 indoor programs every month, our regular meeting, and then our astronomy fundamentals program. Fundamentals will be coming up not next Tuesday, but the following Tuesday after that. Next Tuesday, we actually will be doing a joint session for Adler Planetarium. They're doing a pair of Mars nights for the opposition of Mars. We had one last Tuesday, and there will be another one this coming Tuesday. And we are providing the live feed of Mars from our other observatory for that, because Adler's observatory can't reach down as low in the sky as Mars is, but we can out here. So if you go to the Adler Planetarium and look for their, or just to YouTube and look for the Adler's channel, that'll be streaming there, and you'll be seeing pictures of a live stream of Mars. If it stays as clear as it's supposed to for next week from our other observatory. And if you follow us on Facebook, or if you're a member of the club and just watch the club message board, we will put out announcements when we're going to do other pop-up sessions like tonight, because we don't plan these, we don't announce them very far in advance because they're always weather dependent. So we'll usually only announce a night like this the day before, or sometimes even the morning of the evening we're going to do it. We've also done solar sessions during the daytime and other specialized things like moon observing nights. And so pay attention, follow us on Facebook, or watch our website calendar for our regular programming. And we hope to see you under the stars more. So I guess we'll say good night for the evening, and thanks to Jim in the control room and Frank in his observatory, to Tony here helping in the DuPage Valley Observatory, and then of course to Janet for providing some commentary for tonight's observing. And with that, I'd like to say good night to you all, and keep looking up.